So in this question, we need to find the points on the curve at which the tangents are parallel to x-axis. Okay, so when a line is parallel to x-axis, that means its slope is 0. Pretty simple. So we know that the slope of the line is 0. Okay. Okay. So let's start. So there is one curve. Okay, let us analyze this curve. It's a circle. X square minus 2x plus 1 minus 1 plus y square minus 3 is equal to 0. X minus 1 whole square plus y square is equal to 4. So this is a circle with center at 1, 0. So that means here is the point 1, 0 and the radius is 2 because 4 is 2 square. So this is the point 1, 0. And since the radius is 2, circle will look something like this. Oops. Yes. Okay. So this is the circle. So now we need to find the points on the curve at which tangent is parallel to x-axis. Firstly, I would like to draw this circle again. I think things are not clear if I'll draw it like this. Yes. Okay. So this is the circle. So I guess it's very, very simple. I mean, we know the points which are going to be parallel to x-axis are points which are going to be on the diameter. So this is a line which is perpendicular to x-axis because obviously the line must be perpendicular. That's why we are going to make that. And since the radius is 2, so this height is going to be so 1, 2 and 1, minus 2. That's it. This is our answer. But since it's, I guess, 6 or 4 marks question, we can't do like this. So let me guess how CBSE would want to do this. Okay. So I guess to find the equation of the points where tangent will be parallel to axis, we need to find the equation of this line. Okay, the diameter line. And then we need to solve it with the curve. Then we are going to get two values of x and y. So yes, I guess that is going to be a fine way of solving this. So see, figure is necessary. In every question, just try to make the figure. It will give you, it may give you the answer, it may not, but it will very much make things more clear. So we know the answer, but now we need to do it somehow, theoretically. Okay, so we'll write that since the line is parallel to x-axis, since line, since tangent is parallel to x-axis, that means the slope must be 0 of the tangent. Okay. Okay. And then we are going to write the equation of this line, AB. Let's name the points. Okay. Equation of line AB, which is perpendicular to x-axis. Okay. So the equation is x is equal to 1. I guess this is the equation, isn't it? Because the line will certainly pass through the diameter. That you can say from geometry, that you can comment. But then we need to find the other, we know the exact x coordinates, but we need to find the y coordinates too. So we are going to solve we are going to name this equation as 1. This has 2. Solving equations 1 and 2. And then you'll get 2 y coordinates. I think it's not 6 or 4 mark question. I may be wrong. It's 2 or 3 marks. So then you'll solve these equations and then you'll get 2 values of y as you are seeing here. Okay. And then you can write the points. That's it. Moving on to next question. Okay. Prove that the curve this and this cut at right angles if 8k square is equal to 1. So basically we need to prove this thing using these two curves. Okay. So we know these are two curves. Let's try to draw them. So y square is equal to x is going to look like this. And let's assume this curve is looking like this. And we know that the curves cut at right angles. So in this question, we need to prove that the curves cut at right angles. If 8k square is equal to 1. So basically, we need to prove this thing, that 8k square is 1. Okay, so curves are cutting at the right angle. So what does it mean? So firstly, we are going to write the statement in order to make the evaluator happy. So if two curves are said to cut at right angles, then then the tangents made to the curves at the point of intersection is R perpendicular. Okay. So basically, let us try to draw this thing. So we are having one curve which is y square is equal to x, and we have another one which is xy is equal to k. Okay. So these curves are cutting at this point. According to the definition, if they are cutting at right angles, that means the tangents drawn to them. Let us suppose the tangent, one tangent is here, another one is here. So that means these tangents are making a right angle with each other. Okay. So how can we use this information? So firstly, we need to find the points of intersection in order to solve, in order to make the equation of tangent. So, okay. So we know x is equal to y square, and we can write y as k by x. Okay, we are going to substitute this in this one. So we can get here x is equal to k square upon x square. And then we are getting our x cube is equal to k square. Okay. Okay. And that means x is k raised to the power 2 upon 3. And y is going to be y is going to be k raised to the power 1 by 3. Okay. So these are the coordinates of this point, A point. So now we need to, okay, we know that the tangents to both the curves at this point are perpendicular. So, so we are going to find, that means the slope, the product of slope is going to be -1. When two lines are perpendicular, then suppose they're having slope m1 and m2, and then you know that if they are perpendicular, then m1 and m1 into m2 is -1. Okay. So firstly, I'm going to take this curve x is equal to y square. Okay, derivating on both sides, so it's going to be 2y dy by dx. Okay, so let us take it as m1. So m1 is equal to 1 upon 2y, which is 1 upon 2 k raised to the power 1 upon 3. Similarly, let's take another curve. Okay. So let's shift x this side, k upon x. So we know dy by dx is going to be minus k upon x square, which is going to be minus k upon k raised to the power 4 upon 3, and which is minus k raised to the power 1 upon 3. So I hope I'm doing it right. Yes. Okay. 1 minus 4 by 3 is minus 1 by 3. So it is minus 1 upon k raised to power 1 by 3. Okay. Okay. So now we have our m1 and m2. And we are going to use the condition this, let's name it as star. Using star, we get 1 upon 2k raised to power 1 upon 3 into minus 1 upon k raised to power 1 by 3 is equal to minus 1. So this negative sign is going to cancel out, and we can say 2 raised to power k 2 by 3 is equal to 1. Okay, so okay, let's cube on both sides. Okay, so this is going to become 2 cube, then k square is equal to 1. 8k square is equal to 1. I guess we proved what we had to prove. Yes, this is what we need to prove. So basically it was simple. We needed to keep in mind this property, two perpendicular lines, and then we are done. We just need to derivate and then substitute. Let us move on to